All right. So centroids are not going to be a part of the exam. That's why. So let us start with the first question. The first question is very simple. It is just polynomial division. It says 2x squared minus 5x minus 1 divided by x minus 3. Zain. So to do this, again, you're just going to be looking at the first term x, and you're going to be equating it to here. So the simpler way to do it is you're going to do 2x squared divided by x is going to give you 2x. So this is the value you're going to be multiplying with. So this is going to be your first thing, 2x. And then you're going to do 2x times x minus 3. This is going to give you 2x squared minus 2x times 3 is minus 6x. Going to write down here 2x squared minus 6x. And then remember, you're going to be subtracting all of this from the one above. This is going to be 0. If this is not 0, just know that you did a mistake in the first step. 5 minus 5x minus and minus becomes plus. So minus 5x plus 6x is going to be left here. So if you simplify this, this is going to be minus or plus x. Okay. Once you're done, you bring down this value, minus 1. You will do the exact same step again. You're going to do x. How many times you multiply x into x, which is very simple. It's just 1. All right. You're going to look at this x. You divide it by x. It's just 1. So you're going to be remaining here with plus 1. Okay. This is 1. So plus 1. It's going to be, now we're going to do the multiplication of 1 into x minus 3. 1 times x is x minus 3, just simple. So this is going to be x minus 3. Again, you're just going to put this, brackets, minus x is 0, so we are on the right track. If it's not 0, just know you did a mistake in here. Minus 1 minus 3 becomes minus 1 plus 3. Simplifying this, it's 2 plus 2. So this is your remainder here. All right, this is your remainder. What does the remainder mean? If I want to write the final solution, it is going to be 2x plus 1. Remember, this is your solution. Okay, so it's going to be 2x plus 1 plus the remainder divided by the actual thing that we are dividing. So we're dividing by x minus 3. So 2 over x minus 3. This is going to be your solution for the first question. Okay, very straightforward, very simple. I'm pretty sure you guys are very familiar now with this. Remember, you can always refer back to the older videos where I go into detail for each topic. Now, let's look at the next question. Resolve the following into partial fractions. Okay. Here we have 8x minus 42 over x squared plus 3x minus 18. First thing, we need to check if the bottom part has if you can factorize it or not. How do we do that? How do we check if the bottom part, which is x squared minus 3, plus 3x minus 18, how do we know if this has any factors or not? We solve this as if it's a quadratic equation. All right. How do we usually do that? There's one of two ways. We can either do mod 5-3, which is the easier way. Mod 5-3. So mod 5-3. And then we're going to have our a value is 1. Our b value is 3. And our c value is equal to minus 18. Okay. So 1, 3, minus 18. Press equal. We will find out that x1 is equal to 3 and x2 is equal to minus 6. So that means we do have factors. But remember, this is the solution. So how are we going to factorize? We're going to use the opposite numbers. So it's going to be equal to x minus 3 into x plus 6. This is one way of doing the factorization or of checking if you have factorization. If you get a value with a complex number in it, so for example, in the calculator, if you get I, know that you're going to have to use the quadratic equation here and you cannot factor it, okay, if you get I. But in this case, we didn't get I in the calculator, so we can go directly and factor it. Another way of factorization is we're going to look at the C value, minus 18, and we're going to look at our B value, which is 3. So what two numbers, when you multiply, you get 18, or minus 18, sorry, and when you add or subtract, you get 3. So since the sign here is negative, we know that one of these numbers has to be minus. So First of all, let's write down the factors. So it's going to be either 1 and 18, 2 and 9, and then we have 3 and 6. All of these numbers, when you multiply them, you get 18. And one of them has to have a minus sign, because when you multiply minus with plus, you get minus. So one of them has to have a negative sign. How do we know which one? So we look at two values that when we subtract from each other, we're going to get the value of 3. So which two numbers? 18 minus 1, 1 minus 18, nope. 9 minus 2 or 2 minus 9, no. 3 minus 6, nope. But 6 minus 3, yes. So it's 6 minus 3. All right. So once you find that, you can directly just find that these are your factors, 6 and minus 3. So it's going to be x plus 6, x minus 3. Again, you have to get the same solution as mod 5.3. This is just a different method of factorization if you don't want to use mod 5.3. Now let's actually get to solving the question. So the question is 8x minus 42 over x plus 6 into x minus 3. Simple basic linear fractions. So it's not repeating or quadratic. So it's going to be a and it's going to be b. All right, so a over x plus 6 minus b, plus b over x minus 3. Okay, remember, you're going to now multiply this whole part left and right with the denominator, which is, so you're going to be multiplying by x plus 6 and x minus 3. This will cancel out completely. And then here you're going to do the same thing, x plus 6 times x minus 3. If you notice, now we're going to be remaining with 8x minus 42 on the left side is equal to x plus 6. X plus 6 is going to cancel out if we're going to distribute this. X plus 6 will cancel out with this x plus 6. Okay. And we'll remain with x minus 3. So it's going to be a times x minus 3. And again, the same thing we're going to look at for b. So x plus 6 times x plus 6 times x plus 6 times x minus 3 time, which one will cancel out with minus 3? It's going to be this x minus 3. So what we will remain with is plus b times x plus 6. All right. Again, this is very straightforward. You can always refer back to the older videos where I explained this thoroughly. So we will be remaining with this equation. And now we can start solving for a and b. How do we do that? So first, we since this is a very basic linear one, let's try canceling out a or canceling out b for like in two cases. Once we'll cancel out a and once we'll cancel out b. How do we do that? We look at x minus 3. So the x minus 3 part over here, this will become 0 when x is equal to 3. And for this part, this will become 0 when x is equal to minus 6. صح ولا لا? So 3 minus 3 is going to be 0. And here, minus 6 plus 6 is going to be 0. So this is what we're going to do. So for the first part, let's do this in a different color so you guys can see it. So this is x equal minus 6. So let's start with x equal 3. So for x equal 3, we're just going to substitute the number 3 for all of the x's. So 8 times 3 minus 42 is equal to a times 3 minus 3. So we know that this is going to be 0 plus b times x plus x is 3, so it's 3 plus 6. And now we can simplify and solve for b since a is equal to 0. 8 times 3 is 24. 24, صح? 24. Minus 42 is equal to 0 plus b times 3 plus 6 is 9. Simplifying this more so we can solve for b now. So 24 minus 42 is minus 18, which is equal to b into 9. معناته b is equal to minus 18 over 9, which is equal to minus 2. All right, so we found out that our b value is equal to minus 2. Now we will repeat the exact same thing again for when x is equal to minus 6 so that we cancel out b and find out a. So if I just copy paste this down again one more time so you can see it. Move this a bit down. Okay, this is our equation. So if we substitute now x for minus 6, the equation we're going to get is 8 times minus 6 minus 42 is equal to a times x minus 3. What's x? It is minus 6 minus 3 plus b into x plus 6. Oh, x is minus 6 plus 6. We already know that this, we intentionally wanted to go to 0. That's why we chose that value. So now we can solve for the rest. 8 times 6 is 48 with a minus. So that's minus 48 minus 42 is equal to a times minus 6 minus 3 is minus 9. Minus 48 minus 2 is equal to minus 50. All right. Which is equal to minus 50 kf. Minus 48 minus 42 is equal to minus 90. Sorry about that. Minus 90, which is equal to a times minus 9 times minus 9. So now we could just solve for a. A is equal to minus 90 divided by minus 9. Minus and minus will cancel. So a is simply equal to 10. All right, so we found our values for a and b. Now we can plug in back into this equation to find our final solution. So a plus b, a over x plus 6 plus b over x minus 3. A is 10 over x plus 6 plus b, which was minus 2 over x minus 3. Again, when we have a minus inside, we could just remove it and take it outside, and it will become minus over here. And this is your solution for part B. Very straightforward. We've done this a million times before. Just make sure when you are solving, do not make mistakes in your calculations, in your multiplication, in your substitution, all of that. Make sure that you are very straightforward when it comes to that. Let's look at the next question, limits. So, evaluate the limit, the following limit of x squared plus 4x minus 12 over x squared minus 2x. So we have the limit of x to x as it approaches 2 of x squared plus 4x minus 12 over x squared minus 2x. Remember, if you just substitute 2 here, you're gonna get a 0 in the denominator, which you cannot do. So if you notice, it's gonna be 4 minus 4, because 2 squared is 4, minus 2 times 2, which is 4, it's gonna be 0. So we cannot solve it. We cannot divide by 0. So we have to factor it out and find another way to solve. So the best way to do this is you're gonna factor the top part and the bottom part. So let's look at the bottom part first. It is very simple, actually. You just take x out as a common factor. Let's leave the top part as it is, x squared plus 4x minus 12. The bottom part, it's going to be x into x minus 2. All right, we just took an x out as a common factor. So now let's look at the top part. This is, of course, the limit of x as it goes to 2. All right. So if we look at this part, x squared plus 4x minus 12. This is the only part we're going to look at now. Let's try to factor it. I'm not going to use mode 5.3. I'm going to use the normal factoring technique. So how do we do that? We look at our b and our c. So we're going to look at our minus 12 and we look at our 4. We have a negative here. Let's forget the factors. This is 1 and 12, 2 and 6, 3 and 4, and that's it. All right, these are the factors we have of minus 12. Since we have a negative value, one of these values has to be minus, and we'll figure that out using the 4 over here. So minus 12, 12 minus 1 or 1 minus 12, nope, that does not give us 4. 2 minus 6 does not give us positive 4, but 6 minus 2 does. So we know that it's 6 minus 2, which will be equal to 4. So these are going to be our factors, x plus 6 and x minus 2. All right, so now if we rewrite the equation, this is the equation. We're just going to rewrite it again. So the top part, we found its factors, which are x plus 6 and x minus 2. If you notice now, we can cancel this x minus 2 with this x minus 2, we will remain with the limit of x as it approaches 2 of x plus 6 divided by x. Now we can substitute the value of 2 inside of the x's to find the final limit. So it's going to be 2 plus 6 over 2, which is 8 over 2, which is equal to 4. How can you check this answer? How can you check and make sure this answer is good? So someone in the chat also said it. I could say 1.9999999 instead of 2. In the exam, do not just write that in the exam, because in this exam, they want you to show your steps, and they're not going to give you the full grade if you do not show all these steps. All right? So the one way of doing it when you have a limit of a specific number and it's not infinity, you can assume a number like x is equal to 1.9999999 and just put that in the calculator and solve. زين يعني for this one. So if I do, let me test that out. So 1.9999999, that's going to be my value for x. And then you just plug it in, and the answer is gonna be 3.9999999 something. Okay, this is what the answer I got for it is. So as you see, it is very close to 4. So you know when you're rounding it up, you're going to be getting 4. And this is only used to check. Only to check. Okay? Only use this to check. Do not use this to actually solve the question. Yani, if you guys forgot everything about limits, this is a good way to just put something rather than leave the question empty, but I definitely do not recommend this. All right? Let's look at the next one when there's a limit to infinity. So again, here we have the limit to infinity. When you have the limit to infinity, it's very easy to solve. All right, it's very super easy to solve. What you're going to look at is, so let's write down the equation: 9x cubed minus 2x squared minus 1 over 3x cubed minus x plus 1. All right, when you have this, you're always going to look at the largest value of x. And then the largest value of x here is x to the power cubed. Yani the largest power of x, which is x cubed. The same thing at the bottom, whichever it is. You are going to look at both the top and the bottom. Whichever is larger, you'll take it. In this case, both of them are x cubed. And then you're going to divide everything by x cubed, the same number, the same variable x cubed. So let's go ahead and do that. So the limit of x as it tends to infinity, okay, of 9 x cubed divided by x cubed minus 2x squared divided by x cubed minus 1 over x cubed. Bottom side, you're going to do the exact same thing. 3x cubed over x cubed minus minus x over x cubed plus 1 over x cubed. If you notice here, these x cubes are going to get cancelled immediately, and these can be simplified. So the x cubed in the top is going to be x squared is going to go away, and we'll be remaining with 1 over here. And the same thing here, this x is going to go away, and we will remain with 2 over here. Okay, again, this is to the power of 3. When it's cancelled, it's going to remain as 1. And the last one, we're just going to keep it the way it is. So if we rewrite this again, limit as x goes to infinity, 9 at the top, we have 9 minus 2 over x minus 1 over x cubed. تحت عندنا 3 minus 1. Remember, x is just 1 times x. It's the same thing. 1 over x squared plus 1 over x cubed. Okay? Now, what are we going to do here now? We're just going to plug in this infinity and all the x values that we have. The whole idea was to achieve x's only in the denominators and nothing in the numerators. Why do we do it that way? The reason we do it this way is because we know that 1 over infinity is equal to 0. All right, remember this concept that 1 over infinity is going to be equal to 0. So once you substitute infinity here, we're going to get 9 minus 2 over infinity minus 1 over infinity all over 3 minus 1 over infinity plus 1 over infinity. Keep in mind that infinity squared and infinity cubed is exactly the same as infinity, because infinity is a never-ending number. So the x squared and x cubed does not matter as long as it's x. It's going to be infinity. And we know directly that all of these are going to become 0 because 1 over infinity, or any number over infinity, is equal to 0. All we will have left is 9 over 3, which is 3. And this is your answer. Okay? This is how you would solve a limits question. Now, let's move on to differentiation and integration. Angular displacement of the angular displacement theta radians of a flywheel varies with time t seconds and follows this equation, which is theta is equal to 9t squared minus 2t cubed. Determine the angular velocity, so we need to find velocity, and the acceleration of the flywheel when time is given to be 1 second. So t is equal to 1 second. Now, remember, when we are going from displacement to velocity to acceleration, so it doesn't matter if it's angular or linear. Usually instead of theta, we have x, v, and t. When it comes to, this is for the linear, okay? You guys are very familiar with this, linear. And then you have x, which is displacement, v, which is velocity, and t, which is time. When we're talking about angular displacement, we're going to go from theta to omega to alpha, all right? It's just different letters, but it's the exact same concept. This is angular velocity, this is angular acceleration, and this is angular displacement. Yani it is going in a circular motion. That's basically what that means. Remember, if you wanted to go from here to here, what did we do? We differentiated. So we found dx, or I should do it this way actually. And then, so again, this is linear. This is angular. Okay. So to go from displacement to velocity, we are going to differentiate. So to go from x, yani in other words, velocity is equal to dx by dt. And acceleration, not time, this is acceleration. Acceleration is dv by dt, or it's d2x, the second differentiation of x by dt squared. And you're differentiating x twice. So you're always going in this way, you're going to differentiate. And the opposite way, you have to integrate. Same thing again with angular. It is the same exact concept. So omega is equal to d theta by dt. And alpha is equal to d omega by dt, which is equal to d2 theta by dt squared. Okay? Again, you don't have to memorize alpha and omega in the exam. You could just put a and v. I don't think they will care that much about it. But the usual notation for angular is in this way. So now we can simply solve this very directly and easily. So the first thing we need to find is omega, which is our velocity. Okay? Velocity omega. So it is equal to d theta by dt, which is equal to, let's differentiate. So 9t squared is going to become 18t minus 2t cubed is going to be 6t. So how do you differentiate again? Basic form, this times this, and then minus 1, and this times this, and then minus 1. Basic form, all right? 18t minus 6t squared. Again, we're not just finding the formula, we're finding this at when t is equal to 1 second, right? That's what the question said, t is equal to 1 second. So now we just plug in t for this. So omega at time t equal 1, and then at time t is equal to 1. So this is usually, so let me just rewrite this properly. So this is angular velocity, which is omega of t, right? We can usually write it like this, f of x as a function, or w of t. We could have also write this up here as theta of t. زين? This is the more appropriate way of writing it because it's a function of t. So now t is equal to 1. So we're just going to replace everything here by 1. So 18 times 1 minus 6 times 1 squared. Okay? Now what? So omega of 1 is going to be 18 minus 1 squared is just 1 minus 6, which is equal to 12, right? Yeah, 12. 18 minus 6, which is 12. Again, here the units are not given. They are actually. The unit is given here as radians. The displacement is in radians. So we know that this is going to be radians per second as a unit. And then, remember, velocity is what? Meters per second. And here we're talking about circular displacement, so it is, or angular displacement, so it's going to be radians per second. Now let us find velocity. Acceleration, angular acceleration. And then it's alpha of t is equal to d omega by dt. So it's simply equal to, we're going to differentiate this one more time. So 18 minus, remember 18t becomes just 18 minus 6 times 2 is 12 t, and that's it. And this is our angular displacement formula. Again, at t is equal to 1, we just have to plug it in. So this of 1 is equal to 18 minus 12 into 1. So alpha of 1 is simply equal to 18 minus 12, which is also 6. Not also 6, which is 6. And then 6, what is this? Radians per second squared. And remember, acceleration is meters per second squared. So this, the unit of it is going to be radians per second squared. And this is how you would solve such a question. All right? Is it clear? If you guys have any questions, please feel free to ask. This part B, I'm not going to solve it here. It's just going to be a waste of time because I've solved the exact same question in the previous video when I was explaining optimization. Exactly the same question, the same numbers as well. So you can refer to that to see the solution for part B. Let's look at part C. Find the area bound by the curve where y is equal to 6x squared. So this is the curve. Y is a parabolic function. This function y is equal to 6x squared. All right. And the ordinates x equals 0 and x equal 2. So remember, when we are trying to find the area under a graph, we are trying to determine the specific range where we can find that area. All right. So let us just look at the graph now. Okay, this is our graph. Okay, and we know that this is y equal 6x squared. This is our function. So what were the limits of x that was requested from between x equals 0 and x equal 2? This is where x is equal to 0. Over here, x equals 0. And this is x equal 2 over here. So we need to find this specific area of the graph. Then this specific area of the graph. How do we do that? Remember that to find the area under a graph, you have to do the integration between where you want to find them, so between 0 and 2, of f of x of our function, which is 6x squared dx. And that's pretty much it. So integration, you guys should be familiar with this. So it's going to be 6x cubed divided by 3, going from 0 to 2. All right. 6 over 3 is a constant, so we could just keep it outside. 6 divided by 3 is 2 of x cubed as it goes from 0 to 2. And then how do we do this? So it's going to be 2 x cubed, the first value of x, which is 2 cubed, minus the second value of x, which is 0 cubed. So this is going to be equal to 2 times 2 cubed is 8 minus 0, which is simply just 8. So 2 times 8 is equal to 16 units. This is going to be our units squared technically because we are dealing with area. Usually when I have a graph given to me and there's no units, they did not mention any units here, I usually just write units squared or units depending whether if it's distance or area or whatever, because each box here is considered 1 unit. Okay, that's why I wrote it as unit squared. Very straightforward, very simple graph to solve. Wasn't that difficult to be honest. يعني إن شاء الله يبون لكم شيء سهل كذي في الامتحان, but I highly doubt it. We solved more complicated ones in the previous videos, if you guys want to refer to that. Let's solve the last and final question, which is series. Okay. Find the first 4 terms of Taylor's series. So we know that it's Taylor, so we know we have to have an a value. So a is not equal to 0. Okay. For f of x is equal to cosine x. So we have our function. Our function is f of x is equal to cosine of x. All right. This is our function. Centered at a given value of a is equal to 1. So we know that a is equal to 1. Okay? Very easy, very straightforward. All you have to do, first of all, it says the first 4 terms. So we're just going to look at the first 4 terms of this sequence. Then, so what are we going to do? We're going to go, where was it? This equation is going to be given to you in the exam. Just use it directly or write it down directly on your paper so you know that this is what you're going to be using when you are formulating. So it's f of a. What is f of a? It's f of x, and then we will substitute a for x, and we know that f of x is equal to cosine x. The way I usually solve this is I find the first 4 terms. So this is term number 1, this is term number 2, so this is 1, 2, 3, and this is term number 4. Okay, so this is first term, second term, third term, fourth term. All right. So I know I'm going to have to find the differentiation all the way up to f triple prime. So let's start. F prime of x. Cosine x becomes minus sine x. F double prime of x minus sine x becomes minus cosine of x. F triple prime of x minus cosine of x becomes plus sine of x. All right. So I found my first 4 terms. Now let us find when a is equal to 1, because that's what the question wants, when a is equal to 1. So f of x is equal to cosine of 1, which is, remember here, very important note, radians. Okay, when solving Taylor or Maclaurin series, keep it in radians. Yani your calculator has to be in radians. So cosine of 1 is equal to 0.9998 f prime of a. This is actually a now. This isn't x, so this is f prime of a. F prime of a is going to be equal to minus sine of 1. Okay, minus sine of 1. Oops, I just realized I said keep it in radians and I didn't even change my calculator to radians. Just give me a second. So changing it to radians, cosine of 1 is equal to 0.5403. So minus sine 1 is going to be minus 0.8415. F double prime of a is going to be equal to minus cosine of 1, which is minus cosine 1 is minus 0.5403. And then you have f triple prime of a, which is equal to sine of x, which is 1 in the case of A, and sine 1 is simply equal to 0.8415. Okay? So we found our values for f of A, f prime of A, f double prime of A, and f triple prime of A. Now we just plug it into this equation again. So I'm just going to copy paste this down. So we start f of x is equal to f of A. What is f of A? It is 0.5403 plus f prime of A. What is f prime of A? It is minus 0.8415. So minus 0.8415. Remember, do not make mistakes with your signs here. When it's negative, just keep it inside the brackets as negative and keep the plus outside. Then you can simplify it later on. But always write the plus and then put the sign inside brackets just in case. Then, continuing this, it is going to be x minus A. A is equal to 1. Remember that A is equal to 1. Okay? Over 1 factorial. Plus, again, we will keep on going. So this was f prime. We are at f double prime, which is minus 0.5403. Again, x minus 1 squared over 2 factorial. And then again, for the last one, plus 0.8415 times x minus 1 again, A is 1, cubed over 3 factorial. And that's it. Now you can just simplify this in a calculator, just using your calculator, simplify everything. So this is 0.5403. Divide here, this is minus 0.8415 divided by 1 factorial, which is just 1 in this case, so we don't have to do anything with the calculator. It's just going to be minus 0.8415 into x minus 1. No need to distribute. All right, don't worry about distribution. Plus minus 0.5403 divided by 2 factorial. It is going to be minus, so plus and minus, it will become minus 0.2702, okay, times x minus 1 squared plus 0.8415 divided by 3 factorial, which is 0.1403 into x minus 1 cubed. Obviously, you can distribute if you want. You can distribute into everything and then simplify all the x's and all the x cubes and all of that. But the most important thing is this is our first term. This is our second term. This is our third term. And this is our fourth term. Okay? That's it. This is the first 4 terms of your Taylor series, and we are done with the mock test. Does anyone have any questions about anything we have done so far? So why is it unrad? Because usually when we are doing approximations, just a quick note about in general trigonometry. Degrees is almost never used when you are calculating in math. All right. Degrees is only used when the question mentions clearly 30 degrees, 50 degrees, or find an angle. When they are saying to find the angle, then you can give it as degrees, like 30 degrees, all right, or 90 degrees. In these two scenarios, that's the only time you will ever use it as degrees. When it comes to solving, radians is always the way to go when it comes to actual solving. Unless the question is clearly talking about everything in degrees, it is always going to be in radians. Then when it comes to radians, you can just multiply this as an actual number. This is just a 3 or 2.4. These are actual numbers. Here, this is degrees. This isn't an actual number. This has a unit of degrees. This has a unit of nothing, which is radians. All right. When we're talking about rotation, when we're talking about speeds, for example, or frequencies, we are talking about a frequency in radians per second. We never talk about degrees per second. That is why usually when it comes to approximations and everything, we are using radians. And you will see that a lot more once you get into your future years, yani inshallah. Next year, if you're an electrical or electromechanical student, especially, you're going to see that you're going to use this a lot. Even in mechanics, in mechanical too, you're going to see that angular rotation and yani angular displacement and rotational angular velocity, angular displacement, and angular acceleration. It's all in radians per second squared. You're always dealing with radians. We don't care about degrees. Degrees is usually for trigonometry, when we're solving trigonometry specifically, and then a triangle and we're trying to find the angle, and geometry. But when it comes to algebra, radians is what we use. Any questions about the mock test? It's a very simple mock test. I honestly thought it was going to be a bit more difficult, but this is pretty much it. There's going to be another mock test, inshallah. I'll be solving it tomorrow. And